So today's not a review either, just problems get harder. Today is molarity. Remember it was like 3 chapters into second semester last year where we introduced molarity?
Yeah. We're quickly getting up into the hard, so I don't remember very well.
Okay? So yes, things are getting harder. I think chapter 5-6 test is the hardest test of the whole year. Just because chapter 5 and 6 is the thermodynamics chapter and the gas law. Yeah.
This is going forward to the next.
Yeah, so the next test after this upcoming one
PD
is the one.
R is a .0821. Is that R? Yeah.
Well, one of the R's. Yeah. Okay?
Oh, yeah.
So if you remember, we talked about in regular chemistry how concentration is what we use to identify how many particles are in a certain volume. And we've also said that the word concentrated, if I don't put a number behind it, it can be very subjective because what's concentrated to me might not be concentrated to Emily. What's concentrated to Annie might not be concentrated to Rylan. And so we need to give a specific number to identify, I have this many particles dissolved per volume. The number one concentration unit that we will use, and we will use it a lot, is molarity. I mean, we use it a lot. Okay? All the acid-base stuff, molarity. A lot of our equilibrium stuff in solutions, molarity. We'll use molality a little bit, but most of the time it's molarity because moles is just so important. Because it's identifying particles. Okay? So yes, there's a quick review. Moles of solute, we should know what solute is. Now notice, it isn't liters of solvent, it's liters of the whole solution. So be very careful if they give you the volume of the solvent and the volume of the solute, you have to take those two and add them together to get the solution. Okay? So, this, whoops. I know why this happened, because I moved them all down because I had an issue last year. So let's do this. First one's not so difficult. There's really a couple ways to do these problems. So if you find a way that you prefer to use, that's fine. Get the right answer, it's cool. There's a lot of ways to do this. So, first things first. It says calculate what? Which means I will have to take moles of solute, whatever I get, and divide it by liters of solution. That's how I get molarity. And what symbol represents that? You guys remember?
Capital M.
Capital M is moles of solute divided by liters of solution. All right, so if we look, calculate the molarity of a solution that's prepared by dissolving this much NaOH, strong base, in enough water to make this volume of solution. Okay? Well, if we look at what we have from a molarity standpoint, which unit do we already have that we need? Liters. What unit don't we have? Can we get it pretty quickly?
Yeah.
Yes. Let's do it. You would take your mass of your base that you are dissolving and convert that to moles using what we've been doing quite a bit so far, molar mass. Is it approximately 40? Is it 40 on the dot or is it?
It's 40. What? It's not what I have. Oh, I didn't. You're right. Yeah.
Yeah, usually I'm.
Yeah, you're right. You are.
I mean, it's right in front of me on the paper, so.
I did nitrogen to sodium.
I did that on my quiz.
I did that on my quiz as well.
Okay, so when you do that, you should get a mole number. Now, could you take and do 1 divided by that volume and do it all at one time? You definitely can. Okay, it's up to you how you want to set some of these guys up, but you should get a mole number of like 0.2875 or something like that. Is that right? Yeah. Okay. All right. So my answer is 0.2875 moles and 1.50 liters. actually, to get molarity, I actually have to take the one number, divide by the other number. Because I know I got that many moles in there, but that's that many moles in how many liters? Well, no. How many liters currently? My molarity is per 1 mole. I know I have this many moles per this volume. What is it per 1? So you're going to take and divide that, and you should get 1.192.
It wasn't made a difference. I did 11.5 divided by 40.
I like your
I did something different. No. I must have not done something right.
Well, that's
No, I thought I plugged it in. What did I do?
Alright, does that make sense?
Yeah.
That's not new. We did this last year. This is
I did 11 out of 40 instead of 11.5.
That's fine. Okay? Alright, I want you guys to do the next one. Very similar. Oh, sweet. It even has the exact same spot that I circled. Nice. What did it show?
36.46.
You guys got an answer? Am I wasting my time? What do we get? 1.60 to 6 figs? Anybody not get that? You guys get that over there? Both of you? Okay, I'm not gonna go over it then. Next one. Very important here. This is vital for us to be successful later. More than just figuring out molarity of something, is taking and knowing how to relate molarity of the whole thing combined to molarity of the individual particles. It's the whole idea of pieces versus whole, right? So this molarity tells me that for every 1 liter of this, I have 0.5 moles of the whole thing. But there's a relationship between the whole thing and how many particles there are. Okay, so in this it wants us to find the concentration of each ion. What is the concentration of cobalt? You can just look at it. Nope. 0.5. How did I know that? We need you. If you don't understand where I got that, how I got that, you need to say something because that's important. Who can tell me why? Why is it 0.5?
0.5. That's the
Because what, Emily?
0.5 is molarity.
Because the ratio is a 1-to-1 ratio. Yeah. For one whole particle, there is one of these. So if I have 0.5 whole particles, I have 0.5 of those. Does that make sense? Okay, what would the concentration be of nitrate then? Yeah, probably, yep.
And then in the packet, it doesn't have two. Okay, there's two.
Yes, there's supposed to be 2 here. Is that a typo?
Yeah.
Okay.
Why don't just make it add some subscripts?
Well, you have to push the subscript button and then put in the number and then undo the subscript button.
Okay, so where is it? Another one that you passed with
It's in the top bar of the main
Oh,
screen.
really? Okay.
It's like a little X on the bottom and then like an X above. You do a superscript.
I had no idea I did that.
The old Word documents, you have to actually like right click and then
Yeah.
go to font and then
That's
go
what I was
in.
thinking of, yeah.
Okay, what would be the concentration of nitrate?
1.
So it would be 0.5 times 2, because I know I have twice as many particles of nitrate than I had of the whole thing. So it would be a 1 molar nitrate solution, concentration of all those ions. Okay, and I think if you can see that pattern, what would be my concentration of iron? What would be of, what is that, perchlorate? 3? Everyone see that? Come on, put it down. Let's progress. Because a lot of times, when we start doing acids, do I want the molarity of the whole thing? No. I want the hydrogen concentration. Because that's what it affects pH and things like that. So, let's look at this one. Alright, so first off, I know that I have 1.0 times 10 to the negative 3 molar of my whole thing. I also know that the solution has 1.75 liters of it. He wants to know, what is the concentration, no, not concentration, what is the moles, how many moles of chlorine do I have in this concentrated zinc chloride when I've got 175 liters of it? There's a couple ways we could do this. Okay? We could take this, convert to moles of the whole thing. Or we could take this and figure out the molarity of the ions and then get rid of the volume. Doesn't matter which you do. I don't care. So, do you care? No? Okay. So I know there are 1.0, 10 to the negative 3 moles for every 1 liter of my zinc chloride. I know my solution.
Wait, isn't it?
This is molarity for every 1 liter. I don't have 1 liter, so we're going to have to do a conversion. This is the moles per liter, so it's going to actually be a bigger number once I, right, does that make sense? So I'm going to take it, I'm going to have to times by 1.75 liters so that my liters cancel, giving me with my moles of the whole thing. Do you see why I have more moles than what the molarity is showing me? Because molarity is always per liter. I think I did it different on my sheet, so you're going to have to give me what the total mole number is. Total mole number? This times this? What is it? 0.00175? Now that is moles of what?
Seeds, yeah.
It's not moles per liter, I canceled liters out, that was the purpose.
Moles of the
Moles of my zinc chloride. Okay, well if I got that many moles of zinc chloride, and that thing's gonna break up into its ions, how many moles of chlorine would I have?
2 times that.
You would take this number times 2 because it's gonna break up into twice as many chlorine ions as it would the whole thing. When you do that, you should get 3.5 times 10 to the negative third. Everybody see that? Now, could I have taken this, multiplied it by 2 to get the molarity of the chlorine ions, and then use this? Would have done the exact same thing. Doesn't matter which way you choose. Cool? Alright. too hard, bro. This is the more real life stuff you're gonna see probably on quiz or a test or a homework assignment. Okay, so here we go. We know that typical blood serum or blood has a concentration of 0.14 molar NaCl in it. Okay? So it says if I know that I have 1.0 milligrams of NaCl in the blood, what's the volume of the blood? Because remember, there's a certain amount per liter of NaCl I have. So if I've got this much grams of it, I know there's a certain volume that goes with that. That make sense? Okay. There's a couple ways we could do this. Okay? We could, well, yeah, no, there's really only, I think there's really only one way. Well, there's probably another way, I don't know, but. Alright? I'm going to first start to identify, because I know that this is moles per liter, right? And I want what unit in the end? What's the unit I want in the end? Liters. Okay? Which means I'm probably going to have to get rid of the moles of this. Right? And moles of that's going to be NaCl moles, correct? Well, do we have a mass of NaCl that we could convert to moles of NaCl? And then we could use this as a conversion factor to figure out how much volume that would be. Does that make sense? We got to first take this number and do well with it though before we. Yeah. Then, once we've done that, we can do molar mass, correct? What? That's like 58 point something. 8.44. So I took milligrams to grams, grams to moles, and remember this is moles of what? What? Yep, that's important. And I should put the units all the way through because knowing the substance is just as vital as knowing the unit. Oh, I didn't put the unit in there. Okay? So we know that this mass has this many moles. And we know per 1 liter, I should have 0.14 moles. Okay, well looking at this, probably going to be less than a liter, right? Because my moles is much less than 0.14. Right? Last conversion. Now notice, this is moles per liter, right? How would I have to set this up so the moles cancel out correctly? Yeah, you have to flip this. 0.14 moles for every 1 liter. And that should give me a pretty small volume, I assume. You'll get? Yep. And that would be liters of solution. Because remember, this is moles of solute, and that's liters of solution. Okay? So we've seen forward and backwards of a lot of these different things. So let's kind of take the same idea and go reverse on the next problem. Or do you want to try to do it on your own? That's pretty self-explanatory. Stock solutions are a lot of times what you use in labs is you've got some sort of solution that you know the volume of that you go back to when you need to do a certain technique in the lab, and you make up a stock solution, you put it in a big container, and you know, I've got 5 molar solution of this. And so you can dilute it, you can do all sorts of things to it, but you can always go back to that. That's essentially what a standard solution is. Okay. You guys want to try this on your own or do it together? Okay. It's essentially the opposite of what you just did. Oh, they put it out at 1 liter too, didn't they? Makes it easier. Except for those no milligrams you're converting to at the end. Anybody got an answer yet? Stuck?
I have one better on Frank.
Why? Yep.
Yeah, oh.
It's essentially the reverse of what we did. The previous one we started with a mass and went to volume. Here you started with volume and went backwards, went to mass.
You just,
58.8 grams.
you end up, really the only two numbers you have to worry about are multiplying the 0.2 times the molar mass.
In this case,
The rest of them are all
it's
one.
only because you start. If you wouldn't have started with 1 liter,
Yeah.
you see how one because they started with 1 liter, it was easier. Because molarity is already per 1 liter, so if you know you got 1 liter, you know the moles. Okay? If it were like 2 liters, then you'd have to multiply by 2. Or yes, multiply by 2. All right. Before we do the dilution equation, this is one that actually is one of the most useful equations in all of the lab. It's what you would do if you pulled out one of those stock solutions or one of those standard solutions that was like a 5 molar. Say you had a 5 molar strong acid, and for your lab procedure that you were doing, you needed a 1 molar acid solution. You would take a certain amount of that 5 molar and dilute it down. And you would use this equation to figure out how much volume you would need to add to it. Okay? So it's a really quite useful equation. It just is a relationship, essentially a ratio. Okay? If I have a 5 molar and I want it to a 1 molar, okay, what volume would I need to use or add to that to get to the desired molarity that I need? So that's what this is going to say. And why are those not subscripts? So here we go. Let me show you.
Really, it's just,
Where is it?
Basic.
Ah, this is PowerPoint. I have to do the. PowerPoint hasn't gotten to the point where they know what they're doing. The only thing you got to worry about here is to make sure that you have the correct concentration with the correct volume and you don't flip them. That's pretty much all that you have to worry about on these types of problems. So as I read it, it says what volume of 16 molar sulfuric acid must be used to prepare a 1.5 liter of 0.1 molar. So these two go together. I don't care if they're M1V1 or if they're M2V2, it doesn't matter. They just go together in context. Make sense? What was that?
Just basic algebra.
Yep.
9.4 times 10 to the negative third.
So essentially what you'd be doing here is you would say, okay, I want. This is the volume I want of my new solution. This is the concentration I want. How much volume of my stock solution would I have to pour in, and then I fill the rest up with water. So you would just divide by 16, and you should get a fairly small amount, which would make sense. If I want to dilute this down, I don't need a lot of this. The rest of it's just going to be water. So it should be a really small number. What is it?
9.4 times 10 to the negative third.
9.4 times 10 to the negative third? Yes, that's right. Did I do something wrong, Emily?
Oh, I break grams in the sister's boots.
Why did I do that?
Can you just take a
0.009375
No. So it's M1V1 equals M2V2. This is M1V1. This is M2 divided by M2 times the volume.
So volume is
So that's
It's time.
Make sense? Annie, good?
Yep.
Alright.